And then one day I woke up and I went, well, why don't I just build my own neural network library from scratch in Lua? And you'll see what happens. What's going on, vlog? Today is really weird because I didn't complete my vlog from last night, so I have to edit that. What a Saturday this is going to be. But, so I'll edit that. I'll probably be going out later today, September the 11th, and then I'll work on this vlog to get it out for tomorrow, September the 12th, early in the morning. And that's it for today. So I guess I'm just going to be spending, like the next 6 or 8 hours or so just editing footage, which is always fun on a Saturday, but, needs to get done. And yeah, it's really it. There's not much else to say. I just want to be done with this project, really. Project has been going on for way too long. But, okay. Okay, so what deep Q learning basically is so with Q learning, we had the AI kind of memorize different states. So for example, this, and then I had a whole bunch of different actions, right? So it could go, let's say 1, 1, 2, and blah, 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 until 3, 3. And so basically what it does is it plays around and it goes and it chooses the different boxes or the different actions that it can take. And so after a while, it starts to learn, if I keep making this type of move, eventually the game ends up in a scenario like this where I actually win. And so from there, it starts to learn and starts to take a look at what actions it used to get there, and that's how it learns. And so that all gets stored in a table, and that's what Q learning is. Now, if we wanted to do deep Q learning is a little different, because deep Q learning it doesn't use a table, it uses a neural network, right? So deep Q learning would say, okay, well, instead of having a table where all this is stored in, right, and the table gets exponentially large, and we saw it for the 4x4, it was way too large, and even then it was not fully optimized at the size. What size was it again? So even after it hit almost 100 megabytes, which really isn't that big of a deal, it still was not fully optimized. Now, that's for just the 4x4. So to get it optimized on just a 4x4, a 1D 4x4 grid, you're probably looking at maybe 150, 200 megabytes. And then a 3D 4x4 grid, you're looking at, I can't even tell what you'd be looking at, right? Because the number of states for that would just be way too large. And so you probably get into the gigabytes of data. So to avoid that, we just use a neural network. We feed it the game state. So for example, with a 3x3 board, we feed it the array. So let's say X is here, O is here. So this neuron would be fed X, this neuron would be fed O, and then you'd have a neuron for each of the other different squares that the AI could go in. And in this case, they'd all be blank, right? So they'd all just be all blank. And so then you'd define the network with a certain number of input nodes. Let's just leave that blank for now. We'll get to it later. And so then for each of the different actions, the network will then spit out its predictions for those actions, the predictions of what would actually be in a Q table if you actually implemented a Q table. So basically, it's just approximating, it's just guessing what the Q values would be. Now, this doesn't necessarily mean it's accurate in any way, shape, or form. However, it does start to learn over time what actions are probably better than other actions. So to get that started, we need a neural network. Okay, so a little bit of context for this part, just before we get into it. The whole plan was to use something called Torch in Lua. And so Torch was a well-used neural network library. It was actually the precursor to PyTorch, which is now, one of the main Python libraries for building neural networks. And I thought that it was, it's just a simple library that you download and you install and you reference in your code, but it turns out to be much more difficult than that. And so because it's no longer in active use, downloading and installing and setting it up and everything was a big hassle. And so one thing that I tried doing was I tried, what's it called? Virtual machines. I think it's like a virtual machine. So I installed Linux on a virtual machine, and then I installed. So part of the issue was that the Lua installation process for Windows is very messy and didn't work properly. Again, because they just stopped supporting it, but it still works on Linux. And so I went ahead and I installed Linux on a virtual machine on Windows. And then from there, I tried to install the Torch library on that virtual machine. And it was just like a huge hassle because again, it's not supported. So there were so many issues with the code. I had to go in and like edit some parts of the source code myself. Eventually, I did get it to work. However, the performance was very bad. It was like terrible. And so I said, okay, you know what? The performance is terrible, but maybe when I package it into the final game build, it'll be fine. But you can't do that because that Torch library, it has so many dependencies that need to be like fully installed on the computer for it to run, because it depends on a whole bunch of stuff from like C and things like that. So it has a lot of legacy code behind it. So eventually I just said, you know what, screw this, I give up, I can't do this. This project is dead in the water. And then one day I woke up and I went, well, you'll see what happens.
So instead of giving up, and instead of using something like, let's say, Pygame and coding in Python and going to Unity and learning how to implement the deep Q neural network in language like C++, what I've decided to do is just stick with Love2D. Code everything from the ground up using Lua. Why? I don't know. Maybe it's because I like pain. So what I'm going to do first is I'm going to create the neural network. The neural network is pretty simple. I've done some research, and I kind of built it out in Excel first. It's not the most glamorous, but it helps me understand everything that's going on under the hood, everything I need to code, and everything I need to put in code. So let's get started. So the first thing we need to do is we need to initialize the network. I'm just going to do it in another Love2D program for a couple of simple reasons. Number one, just so it's isolated and it doesn't mess up any of the code that we currently have. And number two, so I can visualize what's going on under the hood. Today, we're going to be doing something very simple. We're going to be recreating something called an XOR gate, which basically means so if we have inputs A and input B, it basically just means either A or B, but not both. So if A or B equals to 1, it's going to output a 1. If B and A are 0, it's going to output a 0. And if B and A are both 1, then it's actually going to output a 0 as well. So it's a fairly simple model. And so we're just going to try to recreate that using a neural network. So we need to have our inputs. Let's call this hidden layer params. Yeah, let's just do that for now. Actually, I'm gonna come back to hidden layers later. Get our input. We'll do that. Okay, and then our output would be. I'll just leave it blank for now. And so the first thing we need to do is we need to be able to feed forward our neural network. So in this instance, basically what we're doing is we are taking an input of, say, 1 and 1. And what we're doing is we are having the network calculate what this should be. And so we're doing that by initializing the weights for each of these nodes, and then we're going to calculate whether or not, or we're going to predict what the final output should be. So we're going to get our initial network. I'm going to initialize what the input would be, or what X would be. The X is pretty much just this, really. So these would be the A and B values that we feed into our network, and then what we're trying to do is predict this output here. 1, 1. What else do I need to put in? Hidden layer parameters. Let's just skip that for now. So pass in X and Y, and there we go. So we have our table inputs, we have our outputs. Actually, you know what I'm gonna do? I'm just gonna hard code build one, and then afterwards I'm going to change this up, because or else this is just gonna get super annoying. Okay, so we have our synapse, we have our input, we have. Okay, so then while feeding forward, all we just really need to do is just take the input of A and then multiply it by weight, by its associated weight, and then take the input of B, multiply by the associated weight, sum them together, and then that will give us the prediction. I'm going to be using a very simple sigmoid activation. There are many different activation functions. I'm just choosing sigmoid here, just for giggles. Let me just test my sigmoid function actually works. What the hell now? Let me just double check this stuff. Yeah, it seems correct to me. Beautiful. Beautiful. So just like that, we have our feed forward. Okay, now we have to implement our loss function. Loss is pretty simple. You just have to do just sum of the losses or the error for each prediction that the network has made. Okay, see how that works? It's not bad. Okay, so now we have our loss function. And now we're going to actually implement the back propagation. I'm not really going to explain back propagation, but there's some resources that are linked below if you guys are interested, and you guys can take a look and learn and read all about back propagation by yourselves. I also recommend this video series by 3 Blue 1 Brown. It was very helpful, instrumental for me to learn how to actually calculate how to actually structure the back propagation formula. Enjoy. So I just took a matrix library and I was kind of refactoring my code and changing up the library a little bit just so it'll work for neural networks. Okay, that still seems to work pretty well. That's kind of what I expect. Let's build it out first without the bias, and then we can add the bias part later. Hold on, that was a sigmoid. The wrong formula here. 1/1 plus e to the negative. Now that is looking good to me. Okay, now we can finally do the back propagation. Oh man, I don't think I need this. Let's make that. Clean up the code base a little bit. I actually need a sigmoid derivative function too. Where in this case, the derivative is just. So we have a few things. We have the y, we have our output, we need our output error. Why do we need the output error? What the hell have I done? And boom. Okay. So we have backprop. So it looks like everything finally works. So I'm just gonna implement a way for it to just loop over a whole bunch of times. And then I'll see how it goes. I'll see what the results of this network are. And then we're gonna have to add a few more bells and whistles onto this because it's quite vanilla right now. We're gonna have to add bias, and we're also gonna have to add learning rate. Those are quite simple, but for now everything seems to be working as well as I had hoped. Okay, so now we're just gonna add some bias. We're gonna add learning rate, and then we should be good.
So what happened after this? Well, what happened was I went down a huge rabbit hole. It was very helpful though. So I learned more about learning rates. I learned more about whatchamacallit. Hold up, now I forgot what they're called. Is it optimizer types like Atom optimizer and things like that? I learned about initialization and how there's I forget exactly what it's called because it's been months since I've taken a look at this, but I'm quite familiar with it. How you should initialize the weights. And so, yeah, I just went down this huge rabbit hole and built in all these features into my neural network library, all from scratch, but it was a lot of fun. I learned a ton, and it's a fully featured, at least at least I think it's a fully featured neural network library. And so that's it. And next episode, funnily enough, I'm editing. This vlog was supposed to go out yesterday, so I'm editing it today. So today's vlog that you'll take a look at later, or maybe it might be coming out tomorrow instead. I'll figure it out. It's I then take the complete neural network and I finally plug it into our Q learning to create a deep Q learning AI. So we're moving on. We're moving on.